All right, so here's the basic rundown of what your test is going to look like tomorrow. All right, first you're going to have a matching section. Okay, so for the matching section, you're going to need to know all of the properties of exponents and all of the properties of radical functions that we've talked about over the last few weeks. Talking about combining them through multiplication, combining them through division, combining them through addition and subtraction, and how we do that. So make sure you study all of those properties. That will be a matching section. You'll have to match one part of that property to its other half.
Is there any vocab?
No, just those properties. Because we didn't really have a whole lot of vocab in these sections. It's all just been those properties. Okay, properties of exponents from section 6.1. The properties for multiplication and division in section 6.2. Properties for addition and subtraction from 6.3. Okay, then you're going to have two different sections of problems. Okay, one of them is going to be like this, where it says to simplify each radical expression. Okay, what else does it say?
Assume the positive.
No.
Oh my God.
This section.
Oh.
What else does this section say? Nothing. Which means what?
Absolute value.
It means we cannot assume this. So we have to be ready for any instance that we have to apply absolute value. Okay? Here, you have a section to simplify radical expressions, right? What else does it say? Assume the variables represent positive numbers. Yes. So, and of course, since some of this is division too, you want to rationalize denominators wherever necessary. And what I mean by that is, none of your answers should have a root in the denominator. If your answer has a root in the denominator, get rid of it. Right? Rationalize the denominator, work it out, make sure your answers are fully simplified. Okay? And I mean fully simplified. That means factored out. That means fractions are reduced. That means the roots are reduced. All that stuff. Yes, Nate?
Can I get some water?
All right, let's start here. Number one, the cube root of 216 over 1,000. Now, you may think that you want to reduce this fraction before you go any further with that. The answer to that question is no, you should not. The reason for that is because if you do, then you won't be able to simplify this fully. Right? Because if you think about it, 216 and 1,000 are both perfect cubes, right? If I go to my calculator and I take the cube root of 216, I get 6. If I go to my calculator and I type in the cube root of 1,000, I get 10. So, the way that you want to tackle this is each side individually at a time, right? Separate it. Cube root of 216 over the cube root of 1,000. And since these are both perfect cubes, they'll come out evenly. And since this is an index of 3, I don't need absolute value because the index is odd. Okay? So that's 3. Oh, I'm already giving the answer away.
Thank you.
That's 6 over 10. But again, our answers have to be fully simplified. Which means this is going to reduce to what?
3/5.
3/5. Exactly like that. Okay? All right. Then we go to the next one, number 2. Square root of 81 over x to the 6th. Okay? Now, this is a square root. That's even. So I do have to concern myself with when I'm going to use absolute value. All right, so 81 is a perfect square, right?
Yes.
Is x to the 6th a perfect square?
Yes.
It is. It's going to come out evenly, right? So this is a even index, so I do have to put absolute value around its square root. Now, do we know what the absolute value of 9 is?
No.
Yeah, it's 9. So I can take the 9 out. And then just leave x to the 3rd in there. Okay? Any whole number, if you have a whole number inside absolute value, you can take the absolute value of that number.
So if we put absolute values around the 9, are you going to take points?
Yes.
Okay.
Yes. Because it's not fully simplified. All right. Yes, sir.
How'd you get down to the value?
Because when I take the square root of this, right, it's x to the third. X to the third is not always positive. And so whenever we take the square root, we're only using the principal root, so only the positive value of the square root. So whenever you take your square root, whenever your solution has an odd exponent, you need to put absolute value around it. If it's got an even exponent, then you don't, because
Even index, right?
only for even indexes or even indices.
So if it was cubed,
If this were cubed, then I wouldn't need it.
but if it was
If the index is a 2, a 4, or 6, or what, then I'll have to apply absolute value. But only if your solution has an exponent that's odd. Yes, Connor?
So what is a 9 now?
Because you can take the absolute value of 9, which is 9. Yeah. All right, number 3. Cube root of negative 12 times the cube root of negative 18. Okay? Well, there are 2 ways that you can go about doing it. Well, not really, but there's really only one way to go about doing it. But if you try to simplify each of these, you're not going to get anything that's able to be taken out. So you're going to kind of have to combine them. But there are going to be some problems where you might want to simplify first before you combine them. But here, this is not the case. So we'll just go ahead and combine them. All right, so that's the cube root of negative 12 times negative 18. What did you say, Braden?
216.
Oh, thank you. 216. We already did that. We already know what that is, right? From this one, right? 6. Okay. For number 4, this is one where if you wanted to, you could simplify it. If you could simplify it beforehand if you wanted to. I'm going to try that with this one. Okay. So let's see. Here I have x to the 7th times y to the 7th times 5x cubed times y squared in that square root. So both of these 7s are odd, so it's not going to come out evenly. Okay? But I can still take out 6 of each of those. Okay? And again, this is an even index. Square root of xy. Okay?
How'd you do that?
There are 6 x's and 6 y's inside that square root. So I can take each of those, take those 6 x's out, right? Oh, like for example, 1, 2, 3, 4, 5, 6, 7. This is a square root, so I'm taking out pairs of x's that I'm multiplying together. That's 1x times 1x times 1x. That's where it x. And the same thing for the y's too.
Wait, where's the 5?
We're not there yet. We're not there yet.
So this is the whole test, right?
Yes.
Yes.
So
Yes,
you
Evie.
used the absolute value,
This is the exact
Yes.
even though it was odd, I thought it was only when
These are odd. When you take them out.
oh, so you use absolute value when the thing that you take out is odd.
Yeah.
Okay.
If these were even, I wouldn't need them.
Okay.
So you just took out the page.
Yeah. Here, all right, guys, listen. Here, I'll take out 2 of these x's and 2 of these y's. Again, these are absolute value
Oh, no.
times 5y.
Wait, why are those absolute
Oh,
values?
because it's odd.
Oh, because it's 1. Okay.
Yes, exponent's 1.
Alright.
Yes, Johnny.
Is that an X on the right? The 5?
No, that's a y.
How come?
Oh, shoot. You're right, Johnny.
Why get this?
It should be an x, yes.
It's a G.
Thank you, Johnny.
Good thinking.
Good job, Johnny.
All right. Now when we combine, here's the thing. So I'm going to combine this with this. So when you multiply absolute values together, the rules are the same as radicals. You can put them in the same absolute value, right? So when I combine these two, I get x to the 4th, y to the 4th in the absolute value. And now I'm going to combine these two times square root of 5x squared y. Okay? Now, here's the thing. Here's the thing here. Now, these exponents are even. So now I actually don't even need the absolute value anymore. Because x to the fourth and y to the fourth will always be positive.
It's very interesting.
Okay? But now, I have an x squared in here. I need to take that x squared out. Now, normally, when I take x squared out, square root of that is x, I have to put an absolute value around it. Okay? So the absolute value of x is always positive. But if I multiply it by x to the fourth, which is already always positive, then that's a rare case where I won't need to put an absolute value. Okay?
On the test, could we put the absolute value if we're not sure?
If you want, like you're talking about writing it like this, x to the fourth, absolute value like that. Is that what you're talking about? Yeah. If you're not sure, you can go with this, and I probably won't take any points off.
You can't just put x to absolute value.
No. Well,
So we can use absolute value like willy-nilly.
no, you can't.
That's not what it
The reason why I'm saying not to do it here is because x to the fourth is already always positive.
Yeah.
Absolute value of x is always positive. So in that case, then a positive thing times a positive thing will give you a positive thing.
But it's not positive, it's just that, right?
Well, no, it is because it's been absolute value.
Oh my god.
Remember, absolute value of x always gives a positive value.
We always assume it's positive.
Okay, and then so I have y to the fourth square root of 5y. Okay.
It's an odd extra.
Wait. Why doesn't the x
Again, this right here is always positive.
right?
When I take this out, that's the absolute value of x, right? Absolute value of x is always positive.
So
So it would be a little bit redundant to put an absolute value around x to the fifth.
But you put it. You could
Put it there.
put it no harm. Well, like theoretically, you could still put the
theoretically.
I'm just not gonna
Not
use the absolute value.
absolute value.
Not quite.
Put it, it would
Not
still
quite.
be right.
It's just
But it would still be, yeah, like Alex said, it would still be
So,
right.
use absolute value.
If you want to put absolute value around x to the fifth, all right, be my guest. But I'm trying to explain to you why you don't really need it there.
Oh, because it's x to the fourth and you add.
Yeah, this is always positive.
Okay.
Absolute value of x is always positive.
So it's just.
So that means that x to the fifth will always be positive in that sense.
Yeah, but then you could do it with anything and you never use absolute value.
No. What he's saying is like the x to the fourth is positive.
By definition, x to the fourth is always positive.
Yeah.
And then when
You
the
could do that
x
for
comes
number
out,
two, too.
it's just
Huh?
Like number two, you could put
Not quite.
30.
Not with this. No. The absolute value of x cubed is always positive, but x to the cubed by itself is not always positive.
put an absolute value there.
Hmm?
If it's not,
It's not
doesn't
negative.
equal each other, you don't need to put. It does.
I just want to continue.
All right. Yes, sir, Sammy.
So for that one, sorry. What I did was I just combined everything at the start. I got 5x10 y to 9.
Yeah, that's what I did.
Okay, but then well, the rule is you have an even index, right?
Yes.
And then you get, so for x in 10th, I got x in 5th on the outside.
Okay. So.
So then I put absolute value.
Okay. All right. Yeah. Okay.
I got everything else right. I just.
All right. So the way that Sammy's talking about this problem here is he's talking about combining them, then simplifying them. Right. When I combine these, that's square root of 5x to the 10th, y to the 9th. Okay. Then by taking out these 10 x's and 8 of these y's, okay, that would be absolute value of x to the 5th, again, because that exponent's odd, okay, times y to the 4th. Y to the 4th does not need absolute value,
That's because it's equal.
because that would be an even, times the square root of 5y.
That was quick.
Yeah.
That's what I got.
So if this works better for you to combine them and then simplify them, then do that, right? Make it less confusing on yourself.
Well, it's just an extra step to not put the absolute value.
What are we talking
No, but I mean like with x to the 10th, right? When I take the square root of that, because this exponent's odd, you have to put absolute value around it.
If it's even, you don't.
Because we only want the positive square root. We don't want the negative square root. We just want the positive square root.
Alright.
This is
Okay.
and
Sweet boys.
this is right. And don't we put the just something irrational? How?
All right, let's go on to the next section here. All right, now this time we're going to assume that all the variables are positive, so we won't worry about absolute values here. Okay, we'll start here. Again, if it's easier for you to combine first before simplifying, do that. I'll do that here.
Wait. Hold on. I'm not talking. Sorry, this guy was confusing.
Fourth root of 96, a to the 19th, b to the 5th, divided by 3, a cubed, b to the 5th. Okay? Reduce that fraction, right? These b's would cancel out. 96 over 3 reduces to, was it 32? Yeah. And then use properties of exponents. 19 minus 3, that's
16.
16. Okay? Now we just need to break that down here, okay? So 32, right? Using its prime factors, we'll say 4 and 8. Break the 4 down to 2 times 2. 8 is 4 times 2. And that 4 is 2 times 2. So 32 is 2 to the 5th, right? I can only take out 4 of those 2's evenly and leave the other 2 inside, okay? So that's 1, 2. But this a to the 16th, the 16th is evenly divisible by 4. So I can be able to pull this out evenly. A to the 4th, square root of, I'm sorry, not square root. 2 a to the 4th times the 4th root of 2. Okay?
That's it.
Yes.
Okay. So you. Wait, is this combining and simplifying, or is this
Yes.
simplifying? Okay.
Yeah, I combined and then simplified.
Okay, so, my problem was I said simplify first. And
Which you can do.
Not do.
You technically still can do that. You can simplify them first and then combine them. It's totally up to you, right? You just gotta watch what you're doing here. Okay.
On this one, it was harder for sure. I could not.
Square root of 12 plus the square root of 27, right? I cannot combine these first until I simplify them. Because remember, with addition and subtraction, they have to have the same index and the same radicand. Okay? So let's start with the 12, right? What's a factor of 12 that's a perfect square? 4, right? So I'll take the square root of 4, which is 2. This is 2 square root of 3. What about 27? What's a factor of 27 that's a perfect square? 9. Take the 9 out. Take the square root of that. Left with the square root of 3. Now they have the same index and the same radicand. But I can only combine their coefficients. I can't combine these by themselves. I have to just combine the coefficients together. 5 square root of 3.
Easy peasy.
It looks so much more complicated.
Coach LeBlanc has a master's degree, so. I'm just saying when you look at the problem, I'm like, I don't know about how.
As Crystal Ball, but I think it's a great point.
I don't know.
Okay.
Going on what I thought that would be.
All right, we got a couple more. We got 18 over the cube root of 4. You all right?
Yeah, good.
Okay. 18 over the cube root of 4. With this, okay, this is a cube root. So at the very least, we want to multiply this by that twice. So we have 3 of these to cancel out that root.
Oh!
Yep.
Oh my god.
So I'm going to multiply this by the cube root of 4 twice.
Okay, alright. I didn't. Okay, ooh, there's a lot of stuff I remember. Bro.
Okay, now, so in my numerator, I have 18 times the cube root of 4 times the cube root of 4. In the denominator, I have the cube root of 4 cubed. All right, now I'm going to go ahead and combine these two. So that's 18 cube root of 16 divided by 4. Okay? So I've rationalized the denominator. Now I'm going to reduce the root. Look at the cube root of 16. If I break 16 down, that's 4 times 4. Each of these is 2 times 2. And so now I have 4 2's in there. So I can only take out 3 of those. Now when I take these 3 out, and that becomes a 2, just 1 2, I still have to multiply it here. So that's 2 times 18. So that's 36 cube root of 2 divided by 4. And now I can simplify that fraction. Did you have a question, Brandon?
So why do you multiply the top by cube root of 4 squared?
Why?
Yeah.
Because it's a fraction. If you change the denominator, you have to change the numerator. It's like an equation. You have to keep it balanced. All right. So technically, what I'm really doing is multiplying this by 1.
So easy.
I mean, it's up to you how you want to do it. But I'm telling you, this. If you can't think of anything else, do that.
Yeah, but you think of any other
If you can think of, if you can,
Roundabout way,
Well, he's teaching
Do you have a
us to
problem?
people who don't understand.
Yes, bro.
if there's an easier way for you to do it, go ahead and do that. It's not gonna, like, as long as it's right, it's not gonna bother me any one bit. Okay.
Not hurt his
But if you forget what to do, the easiest thing you can at least try to do is to come up with 2 more of these to multiply together, so that it does cancel out the root. Yes, Sammy.
Okay, well, if you were rationalizing the denominator 100%, but it wasn't cubed, it was squared, but you just cut it off.
Which one?
Or, well, which is 100%.
This one. Yeah.
If it wasn't cubed, it was squared.
Then you only need to multiply by once. If this was the square root of 4, or let's say this was the square root of 5, then you multiply numerator and denominator by the square root of 5.
Okay, but eventually they all, like the denominator cancels out and just.
Well, sometimes the denominator doesn't reduce all the way.
Well, wait, at the start, like, you see how you do it?
If you multiply the bottom 2 together, they have to equal the cube root. They equal 3.
This is since the index is a 3, I need 3 of these to cancel that out.
What if there was 2?
Then you only need 2.
And it would still cancel out.
Then you would still, it would still cancel
You
out.
only need to do it by 1.
Yeah.
All right, we got one more. One more. Square root of 2 minus square root of 11 over square root of 22 minus the square root of 21. What's that? No. With what? Multiply with what? What about the denominator? I can't multiply the denominator by itself. I need the conjugate. So it's, you're close. I can't multiply it by itself, but I can multiply it by its conjugate. Square root of 22 plus square root of 21. And that's because this gives me difference of squares, which each of those squares will cancel out the square root. Square root of 22 plus square root of 21. Okay? We definitely FOIL out the numerator. First outside, inside last. All right. I need my calculator for this. Let's see. So this is the square root of 44 plus the square root of 42 minus
242.
square root of 242
230.
and then minus the square root of 231. Okay. And then my denominator, square root of 22 squared minus the square root of 21 squared. Okay. Now working with each of these square roots. Okay. Let's look at 44. 44 is 4 times 11. 4 is a perfect square. So
Wait, since it's square root and then square, then it's just 22 and 28.
Yeah.
That's really just one.
that's exactly right. So I have 4 square root of 11. Now if I look at 42, 42's factors are 6 and 7, but 6 is only 2 times 3.
It'd be 2 square root of 11, right?
Thank you, yeah. Yes, thank you. Yeah, 2 squared 11. Thank you for correcting me on that.
Good job, Alex.
So I'm gonna leave the square root of 42 in there. I can't do anything with that. 242. So 242
121.
is 2 times 121. 121 is a perfect square. Right? What's the square root of 121? 11.
Oh, that makes sense. I was like, how's
11 square root of 2.
Wouldn't be a negative though.
Oh, yes, it would be a negative. Yeah.
Good job, Johnny.
And then 231.
I love you, Johnny.
So 231 is 3 times 77. But 77 is 77 is 7 times 11. So I can't factor that. I can't take anything out of here. So minus the square root of 231. And as Cooper said, this is just 22. This is just 21. 22 minus 21 is 1. So this is my solution right here. Okay. Now, before we finish, there's one more thing that I need to tell you about. At the end, there will be a constructed response critical thinking question.
Rough.
All right, I'm not going to tell you what it is, but it is going to involve those properties that we talked about. So make sure you know those properties backward and frontward.
Like the 6-1.
Yes, sir.
The properties are just basically
The properties of exponents in section 6.1, the properties for multiplication and division in section 6.2, and the properties for addition and subtraction in 6.3.
so that's just the rules of solving this.
That's all the rules. That's all the rules that we used throughout this whole thing. Okay,
Well, like,
and it's 10 of them in total, I believe.
10 properties.
10 properties.
I know all 10.
Yes.
And we're gonna like help coach them along with like what's the.
Again, I'm not going to tell you what the problem is, but but it involves using those properties.
Are we helping anybody? Like, is
I
someone
cannot
gonna-
tell you that. I cannot tell you that.
Gotta help Brendan find the x cubed.